Ohad from Ben-Gurion University.
Hello everyone, my name is Negev and I'm a PhD student here in Ben-Gurion University. And today I want to talk to you about my last three studies which focused on prenatal development of children with autism. So to date, autism is mainly diagnosed based on clinical features of children and is usually conducted at about the age of 2 or 3 years old. But nevertheless, earlier signs of autism may be seen much earlier during early childhood. Some of these symptoms, as talked about just before me, is overgrowth of the child head among children with autism. Several studies show that children with autism are born with either a smaller or normal-sized head, followed by an overgrowth throughout the first and second years of life. And other studies which looked on children with autism and took blood shortly after birth show that children with autism in fact have a smaller concentration of neurodevelopmental growth factors among them. Other studies show that children with autism have abnormal growth of the frontal lobes in early life, as well as extraaxial CSF volume about the frontal lobes, giving them some kind of an elongated and oligocephalic head shape. A last study made on brains of children with autism found that their brains have a very dense and concentrated and smaller neurons compared to children from the general population, suggesting some kind of abnormal neurodevelopment during prenatal life. And so researchers suggested that this abnormal growth we see from birth onwards is some kind of a reaction or an adaptation to abnormal growth during prenatal life. Other studies conducted around the globe and also here in Israel show that children with autism are born, have a higher rates of congenital abnormalities in different organs like the brain, the kidneys, the head, the brain, the GI system, and many more. A study conducted in 2019 showed that, for example, children with autism have high rates of ventricular septal defects in their heart. A finding that has been found here in Ben-Gurion very shortly this year by an MD and PhD student called Shira Limelech, which also saw that children here in Israel with autism have high rates of ventricular septal defects. When we look at the genetic data of children with autism and specific genes known to be associated with autism, we see that these genes also affect the growth and maturity of different body organs. And we can see here, just right here like that, close to the mouse. Yeah. We can see that these genes are affected differently during prenatal life and later on during the children's life. And so we believe that some of these genes also affect not only brain development, but also brain organogenesis during prenatal life. When we look at specific genetic syndromes associated with autism, we see that these genetic syndromes are not only associated with autism, but also with abnormal organogenesis, like we saw in a previous talk, which talked about specific gene causing both autism and congenital heart disease. So we can look at, for example, CHD8, these two children. Children with the CHD8 mutation are born with an overgrowth of their head, as well as wider set eyes and congenital anomalies in their heart. Another genetic syndrome associated with autism is the 22q13, which is associated with both autism and abnormal head development. As you can see here in this girl, she has a smaller and oligocephalic head shape, as well as abnormalities in her kidneys. And so there's great interest in understanding exactly what's going on during prenatal development of children with autism. A great tool to example this prenatal growth is using prenatal ultrasound, which is conducted throughout the world from 14 weeks of gestation up until birth, and which collects a lot of data on the children and helps us understand exactly what's going on during prenatal life. Several previous studies examined this data. Most of them were case reports which examined children with syndromatic ASD, reporting congenital anomalies in their kidneys and heart, as well as some small biometric studies which found abnormal head growth of these children. Even though these studies had lots of problems, they had very small sample size. They didn't account for the sex bias known to affect both ASD risk and biometric measures, and they were conducted in different stages of the prenatal life, and so we were not able to understand exactly what's going on. In our study, what we looked at is two main ultrasound screening. The first one is the second and third biometric measures conducted from 14 weeks of gestation up until birth. And the second one is the fetal anatomy survey, which is conducted between 19 weeks and 25 weeks of gestation. We used two data sets. The first one is Collate Health Services ultrasonographic data set, which include ultrasonographic data on approximately 70% of children here in southern Israel. And the other one is the data set of the National Autism Center, which have extensive sociodemographic, clinical, and genetic data on children diagnosed with autism. Our first study focused on biometric measures. So biometric measures, as I said, are basic measures taken between weeks 14 weeks of gestation until birth. And what we measure there are the head circumference, or HC, the head width, or BPD, the femur length, and the abdominal circumference. In our study, we had 174 children with autism, and we matched them to two controls. The first control is their shortest, closest in age, typically developed sibling, and the second control is children from the general population matched on sex, ethnicity, and age. All in all, we had 528 children in this study. When we examined the clinical and sociodemographic characteristics of the children, we saw no differences between the groups, except for sex differences between ASD children and their siblings. In ASD children, we saw, as we well know, a proportion of 1 to 4 between males and females, and while in their siblings, it was approximately a 1 to 1 proportion. So our findings. When we looked at the children's head, we saw that during second trimester, both ASD children and their siblings had a significantly smaller and narrower head, giving it a dolichocephalic head shape, as you can see at the bottom left. When we examined specifically the differences between males and females, we saw that across all groups, males have significantly higher biometric measures, and so we need to see what's the difference between males and females. As you can see here, blue is males and red are females. In males, we saw that both ASD siblings have smaller and dolichocephalic head shape, but during second trimester. But throughout the pregnancy and closest to birth, the sibling managed to close the gap and had the same head size during birth like the typically developed population. While children with autism were left with smaller head shape during birth, as seen by previous studies going from birth and onwards. Another finding we found is that this head shape is correlated with autism severity. This study was published about 2 years ago in the Journal of American Academy of Child Adult Psychiatry. A second study focused on fetal anatomy survey. So this ultrasound is not only focused on specific biometric measures, but look at the whole organ systems of the fetus. It looks on different parts of the brain, the heart, the kidneys, the GI system, the feet, and many more, and looks for either soft markers, which are markers known to be associated with genetic risk, and structural anomalies, which are congenital anomalies later affecting the child during life. In this study, we had 229 children with autism, matched once again to two controls, the typically developed sibling and the typically developed population. Once again, examination of the differences between the groups on clinical and sociodemographic background show no differences except for differences in sex between children with autism and their sibling. Once again, a proportion of 1 to 4 in autism and 1 to 1 in siblings. When we looked at on the proportion of fetal anomalies seen among children with autism, which is black, their sibling in gray, and typically developed population in white, we saw that children with autism, I had approximately 30% of children with autism had some kind of anomaly during ultrasound, compared to 15% among siblings and only 10% among children in the normal population. Also, we saw that children with autism had significantly higher rates of several comorbidities in their ultrasound. When we look at specific organs, we saw that children with autism had significantly higher rates of anomalies in the urinary system, their heart, mainly VSD, ventricular septal defect, or echogenic focus of the heart, which is a soft marker suggesting some kind of genetic abnormality in the children, and anomalies in head of brain, mostly anomalies in the CSF circulation. When we looked at the children's head, we found the same findings as in a previous study. Children with autism had a significantly smaller endocephalic head shape, but while their head was smaller and narrower, we saw that their eyes have a wider set eyes as compared to controls. And these findings are in line with several genetic studies showing that specific genes associated with autism, such as CHD8 or 16p11, affect the distance between the eyes among children with autism. When we looked at differences between males and females in anomalies, we saw that among children with autism, females had significantly higher rates of any kind of anomalies, either head, heart, urinary system, as well as higher rates of multi-organ anomalies compared to males. While in the two other groups, two other controls, we found no differences between males and females. This study was published a few months ago in Brain. Our last study, which we're still working on, wanted to examine what's exactly the genetic background of the children with ultrasonographic anomalies, to see if some kind of a genetic mutation can explain the findings we see on ultrasound. And so we used the pipeline Apurva talked about it before me. The children in our center underwent whole exome sequencing, and we used the tool, the autoscore, for each child to see if you have some kind of genetic mutation, either recessive mutation, de novo mutation, dominant, etc. Of the 229 children with ultrasonographic data from our two previous studies, we had 126 children who underwent whole exome sequencing, and we had genetic data of. When we examine the clinical socio-demographic background between children with some kind of an anomaly on ultrasound and those who didn't, we found no differences between the two groups. When we look at the association between ultrasonographic fetal anomalies and genetic mutations, we can see that children with some kind of ultrasonographic anomaly have significantly higher rates of any kind of mutation, as well as mutations in the head and brain, and mutations in the urinary system. When we look at the different kinds of mutations, either inherited or de novo, we saw that inherited mutations also are significantly higher among any kind of fetal anomaly, among anomalies in the head and brain, and among anomalies in the urinary system. While the de novo mutations were significantly only among anomalies in the head and brain. When we looked at the association between anomalies and the number of mutations, as you can see here, we saw that children with anomaly had significantly higher co-occurring mutations. As we can see, children with one mutation, there were more children with UFA except compared to children with no anomaly, and there were more children with several mutations among children with anomaly compared to those who didn't have any anomaly. Also, we found a significant correlation between the number of anomalies on ultrasound to the number of mutations in a single child. when we use gene analytics to see the association between the specific genes found in each anomaly. For example, these genes were found among children with anomaly in the heart, urinary system, and head and brain. We saw that, in fact, these genes are affecting some kind of the development of these organs, and may in fact be affecting not only autism but also the development of these organs, as we can see in the anomalies in our ultrasound. And that's it. Our study got a lot of media attention, and we hope that in the future further studies could show the same findings, and perhaps this could be some kind of a biomarker for autism during prenatal life, allowing physicians to find some kind of ultrasonographic fetal anomaly, an ultrasound to send them to genetic screening, and perhaps find children with high risk for autism during prenatal life. And that's